Strategy and policy facing track, discussing strategies and policies around research computing and data. So CARC, so let me go back to CARC. CARC is a campus research computing consortium, which is for everyone involved in research computing and data. So all the professionals in different aspects of research computing, which is different tracks, including researcher facing, data facing, systems facing, emerging centers, and then leadership or strategy and policy facing folks. So that's the overall people network, different tracks, and then there are several different working groups apart from the people network, which focus on talking about professionalism in RCD, careers, and so on. Interest groups are looking into new directions where research computing and data is going, and also looking at workforce development and as such. And then there's the logistics and engagement group, which looks at operations of CARC. So that's kind of the overall makeup of CARC. The little bit, next slide, please. Yes, so little bit more info on the People Network is, People Network is like a year-round virtual conference where we have these calls for people who where we invite presenters and they will present on some topics, and then it's more of a discussion after that on that particular topic. The calls normally get recorded and then they're posted on YouTube channel of CARC, so that you can go back and listen to all the previous talks as well. And then within this People Network, there are 5 tracks. Yeah, and you can choose the track that is most appropriate for your experience. We are in the strategy and policy facing track today. Next slide, please. Yes. So to get started, get on the People Network mailing list, and then start attending the calls of different tracks that are most relevant for you. You can also get involved with working groups. The email addresses are listed here. And then just go to carc.org/how to join. And that also explains different avenues that you can get engaged with CARC. So in this strategy and policy facing track steering committee, myself and Patrick are co-coordinators, and then we have Jackie, Jim, Melissa, Preston, Rich, Susan, and myself as the steering committee members. We are always looking for new steering committee members. Steering committee generally meets once a month to figure out what we are going to talk in the upcoming calls. So our upcoming call schedule is we have the topic of trying to see what are the challenges that we face when we deploy large language models for research. That's there. Then the April 3rd call, we have CASC and CNI recap. And tentatively, we have a panel on institutional metadata and then different leadership training programs in June. So that's kind of the tentative planning. So for today's topic, it's going to be led by Jackie on finance and funding for different research computing entities of different scales. And then we all have Jackie is from Northwestern, Preston's from Purdue, and Rich from Cornell. So they are our presenters, and I'm going to let Jackie take it from here.
Okay, is that showing up correctly? Right,
Yes.
thank you.
Yeah.
Okay, so hello everybody. Thanks for joining. My name is Jackie Melhans. I am the director for research computing and data at Northwestern. And so I'm gonna just first talk a bit about in general, some funding, just kind of like an overview of some things to be thinking about. So when I'm thinking about my funding streams, I'm thinking about my budget and key investments that we need to make. when we're thinking about our budget, we create a multi-year budget every single year, usually in the November to January timeframe is when we plan that. And we submit it, you know, in the we're in the quarter system, so in the winter quarter. In that, we are planning as far out as 7 years. It sounds like a lot, but it helps us think about what do we need for next year, and then also for the out years, and signaling what are major investments that we need to be thinking about because we kind of see emerging trends happening now. So, and I'll be watching the chat as well. So capital or one-time funds for hardware, warranties, maybe one-time software costs, those are in our multi-year plan. And then operating or annual funds, things that we're getting, that includes salary as well. But for the non-salary, I'm thinking about annual system software, annual research software licenses, maybe third-party support, or professional development for the staff. Those things hit in our operating budget. And then the other thing to think about is that there are opportunities, like grant-funded opportunities for equipment, new services, staff. We've had NSF CC Star Awards in the past. And then also thinking about your salary budget for staff and if you have student employees. Now, so for capital investments for Northwestern, we have, oh, sorry, I think it skipped a slide. Okay, so funding streams for staff. Most of our staff are centrally funded. We do have a staff member, and we've had multiple staff members in the past funded by either a school or department at Northwestern. What we like about that is that it allows the staff member to have career development opportunities. They benefit from being part of a team because they can go on vacation, they have sick time, they have backup with team members, and they have dedicated management instead of kind of being siloed in a research group. The other thing is that it allows the department or the area to have continuity and redundancy. What I mean by this is that when you are depending on a grad student, they tend to roll off every 4 years or so, or postdocs leave. With staff, you have backup redundancy, and so you can kind of weather those out of office requests or if there's a departure. Now, we also do recharge. This tends to fall mostly on our data science team. So if we have a data scientist working percent time on a grant-funded project, that is when we'll see dedicated or us implementing recharge, or for creating like a custom training workshop or boot camp for a department. That's when we do recharge. That is not something that we prioritize. We really do prioritize the research needs across the university, but recharge does help us in terms of thinking about who are we supporting and what projects do we need to prioritize. However, we do try to keep half of our time focused on maybe underfunded or less supported areas of research. So for example, social sciences and humanities don't really have those large grants that are available to our engineering department or engineering school or a medical school. Other things we have 3 graduate students who are supported by the graduate school at Northwestern through graduate assistantships. So they do things like consult on data science projects, create trainings or workshops for us. And then we also have a salary budget for student employees. So this covers a number of undergraduate employees and graduate students. And so that is in our operating salary budget. And then I've also used breakage to create term positions. So some of you may be familiar with the problem of having funding or budget to be able to maybe purchase software or infrastructure, but you just don't have enough people to actually implement the work. And so when we have those issues and we wouldn't be able to act on spending capital funds or non-salary operating funds, I have requested breakage in the past to create term positions. And the difference at Northwestern between a term and temp position is that we can offer benefits to term positions, and then we will renew them based on performance or need. And then, like I mentioned before, we've had NSF CC Star opportunities in the past. Okay, capital investments. We have about 50% of our cluster is dedicated to a no-cost tier of compute. So this is no cost to the researchers. We do require an annual proposal and to renew that. And they have the opportunity to have up to 2 terabytes of storage in association with that allocation. And then these allocations also access our condo model nodes when they're not in use, so up to 4 hours. So that kind of leads me into the condo model or kind of like a high priority tier. That's not exactly a great way to describe it, but essentially you can purchase nodes on the cluster. You essentially are purchasing 5-year access to equivalent cores, but if it's a high memory node, it's equivalent memory and cores. And what we usually see is it's normally PIs who are purchasing these nodes. You can also request that no one is landing on your node. So I mentioned that, we allow general access users to access those nodes for up to 4 hours. You can pay off the subsidization that we normally cover if you need immediate access because you do interactive work or something like that. And then we have large purchases from our medical school and a couple of other pockets where they have kind of like a shared model for their nodes. And then we're also exploring other models for GPUs. They're just increasingly expensive, and so we're looking at ways to make them affordable for our researchers. And then storage for HPC and desktop mountable storage is offered, and we subsidize that cost. And what we want to do is incentivize researchers to be able to use centralized storage to reduce both risks to data loss and also for data security. Okay. I just want to briefly touch upon challenges that we're seeing currently. So if we're offering free storage without incentive to researchers to maintain their data or manage their data, delete data that they don't really need, it does result in high costs for the institution. So we really have to figure out the model between what incentivizes researchers to store data in safe places or secure places without making it enormously expensive to the institution. GPUs are becoming increasingly more expensive and out of reach for most of our researchers and institutions, frankly. And so we're looking at ways of how can we share GPUs, or how can we think about GPUs, especially because they tend to go, out of date, or they are kind of updated. The architecture is moving very fast. And so how do we provide modern GPUs for our researchers at an affordable cost? And then compute node density is becoming greater. So we're moving to direct-to-chip liquid cooling. However, this does impact our data center investments and also really planning with our vendors, and it has long-term impacts on what infrastructure we can bring into our data center. And then the other thing is experienced staff is hard to find. I think that from our experience, the workforce is low in this area in numbers compared to the demand. So we see more and more universities really needing this kind of workforce, but it's really requiring us to train up our own, or they can be hard to find. And then finally, I just wanted to talk about sustainability. So some of the things that some of the things to think about are utilizing national resources, like access, securing your operating or multi-year budget if possible. It helps you also socialize future expenditures. So for example, one of the things we saw was increasing costs for GPUs. And so increasing that budget, a few years out kind of signals this is going to cost a little bit more, especially if we continue to recruit faculty who are using GPUs. And then one of the things I would suggest is developing key relationships. Just like every other higher ed institution, there are leadership changes, your president may change, your VPR, your provost. And so having continuity and champions and people who understand your impact is important to continue to kind of build or keep budgets in place. And then, concentrating on doing a few services well, cleaning up those services, doing automation where you can, making them run very efficiently before adding new ones. It just reduces your effort for those services. And then setting realistic expectations for your institution and faculty and students on what you can and cannot do. And then ask for help. So attend these calls. I think that they've been really important for me in Northwestern to be planning and doing things in a more strategic way. We've definitely learned a lot from our peers through these networks. And then, metrics, they always help you, they can support your case, make arguments for things like if you see increased wait times in your cluster, maybe the university needs to invest in more nodes, or you can use metrics to help you make decisions around, your strategic planning. And then, as always, collect stories, quotes, feedback emails from faculty and students who are singing your praises. Those are really key to have to kind of demonstrate and tell the story of your impact, but also it's important to save those who communicate key service gaps. So things like, we don't see this at Northwestern, is really important for me to say, this is where we need to be investing next. So if I see a pattern of that, it kind of signals to me that that is something that we need to be thinking about in the out years. So with that, I will stop sharing. And then pass it on to whoever wants to go next. And then I guess we'll take questions at the end, if that works. But otherwise, I'm happy to answer questions in the chat until then.
Thanks, Jackie. Who wants to go next, Preston or Rich?
I can go next.
Go for it.
Okay, I don't have a slide deck, so sorry for that. I do have a couple of diagrams I might be able to share, but my penmanship isn't great. So if people are willing to play along with this, we can try this out. Let's see here. All right. Let's see here. You can see all of that and how terribly I write, right?
Yes, we can see it.
Yep.
And I can
Okay.
read it too, Rich.
And you can read it?
Yes.
Amazing. Okay. I just need that menu bar to be gone. I apologize. This is what it's like at the cutting edge of technology. So Center for Advanced Computing at Cornell is essentially a full cost recovery facility. And the way that we operate is like a computational core facility. So as you may know, back in the 80s, CAC was the Cornell Theory Center, and it was a fully funded national supercomputing center. That funding was not continued, and CAC needed to figure out a couple of different ways to move forward. There was a big agreement with Microsoft, resulting in one of the first, I think the first commodity Microsoft HPC cluster. We all know where that went. And as things evolved, what was really found was that in order to fit well within the Cornell, the rest of Cornell culture, it needed to move to something where faculty could pay their own way. They could get the ability to purchase the services that they need and have a lot of control over what they do. So let's see if this refreshes actually. Oh, it's locked up. Hang on. There we go. Okay. So CSC is essentially offers 4 simple services. The main service that we offer is expertise. The people of Center for Advanced Computing are our strength, and our consulting consists of about 4 times more recovery than the rest of our services. It's about 75% internal at this point and 25% external. That needle has moved back and forth depending on the mix of external projects that we take on as with a PI in the center. So if we're working for a PI at Cornell, that's an internal subsidized rate, and our rate is adjusted to be ideally competitive with but still respective of the fact that we have computational scientists with PhDs working on projects. If it's a project where, for example, I or someone else at the center is a PI, it's not really doing necessarily a service for Cornell, so we can't subsidize it, and that becomes an external rate consulting project. The other service we offer is an on-premise, on-demand cloud service. It's built on OpenStack, and it uses a subscription model. So you buy a set of core hours at a regular rate. There are discounts when you buy bundles of more of them, and then you spend it down like it's a Starbucks card. So if you have a single subscription will get you 1 core year. So if you wanted to set up a single core web server, you could run it for a year with a subscription. If you wanted to run a 28 core computational system, well, it's gonna eat up that subscription a lot faster. So so we provide this on-demand service. There's no queuing, there's no job submission by default, and researchers can do whatever they want. They can use Linux images or Windows images that we've prepared. We have some GPU images that include the libraries, so it's not quite so much of a lift to get it integrated if you wanted to use some of the GPUs in that system, as well as researchers can bring their own images and run them as long as they want. They have administrator access. And that works really, really well. We provide a warning system to let them know if they're going over, and they basically purchase more subscriptions as they move forward. There's some modest GPU resources. We have a virtualized cluster system. So if someone's really used to job submission and they want to do something that really only occurs, a few times a year, it's not something that should really be a dedicated resource. We have a way to build a head node and have elastic workers so that you really only get charged for the time when your job is running. And we also have a means to buy in. So what that means is if people want to have dedicated resources within Red Cloud, then they can purchase a server. We join it to the OpenStack cloud, and then they get rights to those instances. They're sort of fenced off from the rest of them. We also have a managed cluster service where we architect things for people who do want to own their own thing and run it as an HPC cluster. If it's going to be 75% or more utilization, we recommend to do that. I mean, right now we have 18 clusters and about 700 nodes of vastly varying age and lovableness that we've managed to amass over time, and people tend to be fairly happy with that. If it's based on the consulting fee, and you pay a monthly price to have updates, changes, permission fixes, partition changes, or whatever you might need. Again, the researchers have admin access. If they break it, they get to keep both pieces, or we can fix it for them at our regular consulting rate. And with every additional node, the cost per month gets lower. It's sort of a log model where we recognize that adding additional compute nodes to a cluster doesn't really necessarily put more weight on us. And then finally, we have a storage backend for the cloud service and an archive service. These are really essentially, services that we need to provide, and which we, oh, my tablet went to sleep. It's Godzilla. I'm sorry. Services that we need to provide in order to have things work. The archive service is similar, like an extra copy of your data. And I sort of regard these as essential, but it's kind of a loss leader. Like we recover a minimal amount on this, but these are capabilities we have to demonstrate relevance and be useful to the community. So we do get a subsidy from the Vice Provost for Research and Innovation. That subsidy essentially sort of helps us with administration, external relations, and leadership. Each of those pieces at the top there also can bill time, however, so it's not as if it's fully subsidized. There is some recovery built into that. And then we have invoices to Cornell faculty and invoices to awards, and those go into what keeps us running. The terrible thing about this model is we have very little slack to write proposals, to engage in any kind of, testing things out, trying stuff out, or bringing in new technology. We also don't have a real capital budget, as you'll notice. I didn't write capital anywhere in there. So what we do in order to extend our systems, like Red Cloud, is in the past we've used award funds to be able to invest in that. We've also used some creative means through agreements on campus, working with different teams to bring things online. But one of my goals is to really establish a beachhead to say, with our new vice provost as of last year, we have to have something. We have to have a basis to move forward. So I mentioned the terrible part of this model of having no slack to be able to generate things. The nice thing about this model is that we are highly motivated not to say no to faculty. In terms of adding new projects, and if we need to add new people, at this point in time, the demand for consultants, including systems consultants, to engage with things has been on an uptick, and we've, essentially we can continue to look for folks to fill this role and participate, and they start recovering very quickly for us. The other nice thing about projects like this is that while we don't want to turn any faculty away, we have a built-in sunset on projects, in that if someone brings us a project and they no longer have funds to support consulting for that project, it has to be sunset. So there's nothing that we keep around for really the long term. And so as long as we can keep our faculty happy and keep the relationships that we've built over time working, it's really been a successful model for us. So the question really becomes, I think, in terms of long-term sustainability, is how do we balance and how do we look for where we want to grow and where we want to meet the needs of the community, and how do we truly fulfill the idea of being the advanced Center for Advanced Computing rather than simply the System for Adequate Computing, which a lot of the stuff that we do is sort of general purpose right now. We're not exploring a lot of emerging technologies. We do have people involved in projects that are really at the edges of things, but each project is what brings us forward. We're not necessarily sort of setting and developing tone for the institution. So I think that covers in a really tight nutshell what we do at Cornell. I'm happy to take questions at the end. Preston, if I'm going to hand it off to you.
Okay. Let me see if I can find my tab here. Oh, great. All my PowerPoint windows show up as unknown. One second. Make sure I don't share the wrong PowerPoint with you guys. Okay. So I like to update my PowerPoints on the fly. Oh, geez. Hang on 1 second. macOS wants me to allow Zoom. Okay, see if this works. Sorry about that. There it is. Okay. Can't tell we're a team shop here at Purdue, so. All right. So I'm going to talk to you briefly about the financial considerations for our campus CI here at Purdue. You know, my glib response, since I like to update slides on the fly, is to borrow Rich's graphic here. You know, we kind of split the difference between you know, what Jackie described. In some ways, we do a lot of capital planning up front. We have like a 7-8 year roadmap for what we think we're going to be doing on our life cycle and system building. But but we also have a lot of these same constraints that Rich describes. We do cost recovery. We are subsidized though, so I tried to draw this line here to show you that the line for where the university is subsidizing us is maybe down a little further. It basically subsidizes the people, most of the people that support our cyber infrastructure, but with some of those same drawbacks that Rich described. You know, we also don't have a lot of slack capacity, particularly in our research software engineering area, for when new projects come in. The faculty member says, "I've got a sack of money, I want to do something." Well, then you got to staff up to do that, and there's not a lot of room for experimenting and writing grant proposals. So, you know, for my prepared remarks here, you know, the bulk of our business is our community cluster program. I won't go into details here because I suspect, you know, many of us operate some variant of a condo computing program. You know, we started our community cluster program in the early 2000s for many of the same reasons. People were doing this stuff on their own, so we centralize it. The general idea is that you get what you put in, you get opportunistic access. IT does all the work, and you don't have to. You know, one difference I think with our model than what Jackie described is our barrier to entry is you have to pay to play. If you buy one node, you get access to your node, you get opportunistic access and all that good stuff. But that's the barrier. You can't just show up. You know, there's no generally funded access for people who don't put something in. It can be small, but you have to put something in. We do build these on a 6-year cycle. So every 15-18 months, we build a new system. You know, build it out there. It's like filling an airplane when you're boarding, right? It fills up to capacity. It's about 2/3 of the way full. We start the next procurement to get that next slug in capacity. A couple of financial considerations that I think are real important. How we do this is that we set ours up as a recharge center. So it's a fully costed rate with our sponsor programs office and our managerial accounting folks. So it's, you know, all of those things tie out. The subsidy is baked into the rate, and it shows up as a service. So when the faculty member buys a compute node, it is not a capital purchase of a piece of hardware that they can put their hands on. It is a service of access to the cluster, which coincidentally happens to be the same price as the node on the quote from Dell or HP or whoever. We also do have an F&A waiver in place for this. This, of course, is we know from working with faculty, it's not only good, it's important from our financial people's perspective, since it's really capital under the hood, but it's good for the price setting. If you're adding a 50 or 60% tax on top of that price just because it happens to be built as a service, that's a great way to disincentivize faculty from using the central resources. As far as funding sources, you know, I'd given this talk to our campus IT organization a little bit to tell them a little bit about the wild world that we live in research computing. You know, I think they may think we sound mercenary since everything is like, well, are you going to pay us? I would, of course, say that's entrepreneurial. But you know, we all live in a world where we've got to be identifying where these funding comes in, where it's going to come from. Our breakdown that we have here in our organization is shown there kind of in the center on the left. The general funds and the subsidy is about half of our budget, 45%. Our recharge revenue from the actual cluster sales themselves that goes into funding the depreciation accounts and the future life cycles. It's about 30%, and then external sponsored research, contracts, and gifts is another 26%. If you really dissect the numbers under the hood, most of the people costs the sysadmins, the facilitators, all those sorts of people that make the cluster program go. Those are baked in the finances in the subsidies coming from IT. Sometimes there are special projects that are funded by other units. The provost office is doing a data science initiative one year. There's a life science initiative in a different times. Oftentimes we can get part of an FTE or a whole FTE funded through those. But those are, those are, you got to be opportunistic on those. Those aren't really recurring streams that we count on here at Purdue. One of the things I wanted to touch on briefly, and Jackie alluded to how important this is when she was talking, is being able to sell the value of what you're doing. And if you're interested in this topic, I can babble at length for quite some time. And I'm sure there'll be opportunities where I give a very long version of this talk. But some of the things that we do here at Purdue is we get questions like we all get. What are you spending the money on these machines for? Why is there a subsidy on that recharge center? And if you're not careful, it's hard to get the finance people able to understand what you're doing here. But it's important to remember what everybody wants to hear. The message that you give to a faculty member or the provost about outcomes or getting that next grant is not at all of interest to the CFO. At the end of the day, he wants to know about the bottom line. And it doesn't really matter about the number of graduates. Student success. Every one of these audience members that are important stakeholders for you to communicate your value has different things that motivates them. So we always try to tell our story with different types of metrics for different audiences. Tying your research computing resources to outputs like sponsored research or anything financial resonates well with both your VPR, your president, and your CFO. So we always try to point out things like 60% of the grant awards that happened at Purdue were to people that are using our systems. So if you want to make that case that we need that new supercomputer, we need to add all those GPUs, you tie that back to the size of that pie in the university's portfolio, that'll go a long way. And we've used variations on I gave a version of this slide to our board of trustees just in December as we were making our next HPC investment, and to really emphasize the scale of resources that are needed to do AI. And you can kind of see how that's evolved over time. In 10 years ago, 12 years ago, the vast majority of the research dollars were by people that didn't use high performance computing every day. But here by 2022, 2023, that relationship is flipped. The computationals are the ones doing all the work anymore, and that's an important thing for our decision makers and the people holding the wallets to remember. But like on the flip side, though, the provost wants to hear probably much different things. So I've gotten a lot of value in showing tying back the HPC investment and requests for more resources to the student outcomes. If you're able to quantify the number of degrees that your resources enable, that's gone over really well. Tying out, if I can say to our admin, that 27% of the earned doctorates at Purdue last year were HPC users. That's a golden anecdote. Jackie specifically mentioned those qualitative anecdotes. I mentioned the board of trustees meeting here in December when we were talking about our next HPC investment. As luck would have it, the student trustee, the student member of the board, is a mechanical engineering student whose advisor uses our HPC systems, and he chimed in after the CIO was giving his presentation and was able to tell the entire board straight from his own mouth how none of the work that they could do would be possible if it weren't for the HPC investments that we have. So those types of anecdotes, if you can get somebody to say that in public in front of the right people or put it in writing, those are as good as gold. But at the bottom line, if I'm in an elevator with the CFO and want to boil it down to, I like to have messages like this in my back pocket. We sit in central IT, so we have less than 9% of the total IT budget in my organization, but we're able to, with that 9%, we serve $363 million of research expenditures, which from the CFO's perspective, it's a 48x return on investment. So any CFO loves numbers that big. So figuring out ways to communicate your impact is a key strategy we should all have in our portfolio. And that is the end of my prepared materials.
Thanks, Preston. So I think we have time for question, and there's some questions in the meeting notes. I think there's one for Rich.
Yeah, so for competition with public cloud rates, we compete really favorably, I would say. I haven't done the modeling in a little while, but it's important to note that what we provide is that it's complex to compare, right? Because if you're working with Spot or you're working with 3-year reservation, there's a pretty wide variability in what you get. But we provide cores with 8 GB of memory per, and we don't oversubscribe cores or memory, so you get real access to real hardware. And so based on a comparison like that on-demand pricing, we're able to provide, even with some of the the basic like the single core instances, it's about 40% less than what EC2 would be. And then when it gets to like GPU instances, fact that we have fewer of them, considerably fewer of them, it's a really small amount. I think it's 60% off what EC2 was charging at that point, and that's before faculty does any of the bundling discounts that we provide. So when you buy bundles of subscriptions for us, you get at 8, 16, 32, and 64 subscriptions, you would get a 10, 20, 30, or 40% discount. So when we have really intense users, they're able to get their work done for cheap because we know that they're going to work on the cloud and get results. The other piece when we're designing rates and services is what we look for providing people are things that are like as little overhead and as little FTE time as possible. So our archive service does not have file system access. It's Globus only. There's no, there's no question of somebody going in there and making permission changes. Other than that, you just access it with Globus and put stuff in or put stuff out. You can script it, you can share it, you can make a public endpoint, all these things, but it's designed to be as little FTE intervention as possible to really drive things down. And we try to do that in a lot of ways. Just on that same subject about elasticity, the way that we've worked it out so far is the demand does not vary super heavily I mean, there's some demand over the course of the semester that we see, and what we do is we keep a high watermark, and when we start to see utilization get above that high watermark, which is about 75%, maybe 70%, we start looking for more resources, and we really watch for when instances, when you cannot start new instances because there's too much congestion. We do not have currently like any kind of burst or spillover, and that's something that I'd really like to be able to support, but we really haven't had the level of demand that's really outstripped what we provide. The question for me is when do we call it good as far as providing an overall resource, and when do we say you just need to go to the public cloud because we're not a scaling facility. We are, we're a modeling, trying out, low barrier to entry, but also low penalties to going over your time facility.
Thanks, Rich. I think there's more questions in the chat. I think
Jackie or
Yeah.
Preston, do you want to comment at all on the questions that were in the doc?
I can just
It is.
quickly, I'm finishing typing it, but the question was, what's the cost recovery target and how's that derived? So for our HPC cluster, it's about 40%. is kind of the minimum we're shooting for. We like to have about 50% of our cluster available for general access. And so, and somewhere between, 40 to 55% would be cost recovery. For storage, especially for our desktop mountable storage, we take on more of that cost. The university takes on more of that cost just so that people have are being responsible with their research data, and so kind of incentivizing responsible practices by using centralized resources. And then for staff, our compute staff, really, we don't have recovery targets for that, but for our data scientists, statisticians, and our data visualization specialists who directly work on projects or are making, dedicating time for those projects, for the time that they're dedicating, we try to recover about 50% of that. So, and then maybe the other half dedicated towards folks who maybe don't have funding available to them in the amounts that, engineering and the med school or others, physical sciences do. So for example, if I was typing out, if someone spends 20% of their time doing dedicated support for projects, we try to recover about 10% of that, because, and the other 80% would be doing workshops or developing workshops, doing short consults, and other kind of things that staff members have to do.
Can you just jump in? Do you have a different model when you think about cost recovery for staff? Or, I know that most places have some use of grad students for some amount of a support. Do you think differently about them than you do about professional staff?
We used to, but our graduate students do take time from our more senior staff members, because it's a senior staff member or a manager who is providing the mentorship, making sure that the service is conducted like a professional service, helping people understand, or students write the scope. And so there is this kind of background involvement that is a lot from the staff member, but for us, it's worth it, because the students allow us to have a broader, a broader portfolio of experience and backgrounds because of all the research that we support. And also, I mentioned, the workforce is small, and so we've been able to hire on students that worked for us as students, as staff, when they've graduated and decided that they want to stay on.
So actually, I had a follow-up to that. You mentioned like in December, you presented that you had a relatively rapid expansion of your team. So that suddenly would have added a lot more salary to the expenses side. So are you still aiming for 40%, or is that gradual? And then, and have you been communicated that is there going to be a ceiling that you get to see that this is the max dollar you'll get subsidized by?
So for for capital, when we're keeping the same targets, a lot of the investment was for support staff to enable research that otherwise wouldn't happen if you had an experienced data scientist on your project or a computational specialist. And the university really does want to see increased data science maturity and computational maturity in our social sciences, in our humanities, in our non-traditional areas, in our medical school, which has been a user for probably about 7 years in a big way. But the target isn't to completely recover costs on those staff members. It's really to propel Northwestern forward as a leader in these areas. And so we're kind of figuring out what those recharge targets should be, and kind of trying to balance out the research that we're supporting in more traditional areas and non-traditional areas, which is, I think, a very fortunate place to be. We have more room for exploration because of that.
Right, thanks. I think, Preston, you have a few questions here.
Yeah, I think there's kind of two that are around F&A waivers, so maybe I can just kind of address both of those. The one in the document was having an F&A waiver for faculty using cloud computing. We do not have a waiver for cloud computing. Probably a number of reasons there. I would say that we are not a terribly mature institution, business process wise, or even the use of like public cloud as you might think. So we don't have a lot of faculty doing that. We have a couple situations like our CUI environment for Azure desktops is an area where I've already seen in 6 months or so that an F&A waiver would be really valuable for cloud computing. So I think we do need to have that conversation, but it's not come up yet. And I don't know that there's anybody really pushing for it yet. I think once the faculty start getting some of those bills, then they'll probably advocate for that. There was also the one here in the chat about how did you all go in getting the F&A waiver in the first place? That's a great question. I can probably share some of the documents from that. I've shared that with various other institutions over time. I think when it was set up, it was largely from the perspective when we set up went from a capital purchase model, and this was 12, 13 years ago. So it's been a while. I was a lead sysadmin at the time and not necessarily in those conversations, but I think it was basically around it was around the disincentives piece of it. You don't want to penalize somebody with that extra 55% tax just because we're building it as a service. There had been some financial people, and even our CIO was asking questions about why do we have this F&A waiver here? That's money that could be going to the university. But I was actually surprised to hear that our sponsored research office strongly advocates that we have to have the F&A waiver. I think from their perspective, since under the hood it really is capital, it's not appropriate to put the F&A on top of something that's really capital. But if you want to get really deep into the guts, there is a person in our sponsored research office that has done a lot of work on this particular topic. I could probably facilitate a deeper conversation if that's of interest.
If you have some documents, do you mind that are publicly accessible? Do you mind putting the link into the meeting notes?
Sure, let me see if I can find them. Yep.
That's great. Thanks. I think there's more questions that came up about GPU as a service. I think it's both. Anyone can go ahead. I think it was meant for Jackie, and I think you did answer that in the chat.
Yeah, I don't
You want to
know.
make a comment?
We're looking at other options. I mean, we've always done kind of purchasing the node for 5 years kind of deal, or replacing it at about the 3 or 4 year mark if the hardware is getting old. But we are looking at even leasing GPUs from vendors to make sure that we aren't stuck with old GPUs that researchers really don't use. We find that our researchers really use the newest GPUs on our cluster, and then our older ones kind of go unused. And so we're trying to figure out how do we optimize our power, cooling, and space, going back to the data center challenges, while also, making it affordable for researchers who really, if they need like a 8-card H100 SXM GPU, it is incredibly expensive for one researcher even to buy one single node. So how do we think about enabling sharing, or really figuring out how to make that affordable for researchers?
And I think that's actually a great transition, if you will, to what we're going to be talking about next time, which is the challenge of supporting these large language models, including these data center and cost challenges, as well as support and other things. And although this has been a really great discussion, and I know I've got a bunch more questions I would like to ask, we are actually at the top of the hour, and I don't want to run way past since most of us have back-to-back things. So thank you very much, Jackie, Preston, and Rich, for coming and sharing all this. If you can, Jackie and Preston, dump your slides into or send me the slides, and I'll put them in the folder so that we can link to them. If you want to make it a PDF of the slides or however you want to, that's fine. But it's great for people to be able to take a look at those again. We will post this recording once we get a chance to process it through, and it'll be up on the YouTube channel. So if you want to share it with anybody, please do. And with that, I think I'm going to turn off the recording unless there's Any other last minute comments from any of our speakers? Nope. Well, again, thank you all very much, and thanks everybody for coming. Your questions, your participation make this all great. So thanks very much.
Thank you.